All right, hey guys, we are taking a look here at section 6.2. All right, systems of equations in three variables. So in section 6.1, we've been working through linear systems involving two variables. We talked about how to graph those, how to solve those by elimination, by substitution. Today we're going to kind of jump to what if this thing involves three variables like ax plus by plus cz equals d. So we talked about x and y. What if they throw this third variable in there, z? Now, again, yeah, you guys are probably, I know you're familiar with the x-axis and the y-axis. Now we're throwing in this z-axis, all right? Not sure how familiar you are with that, but the z-axis goes right through the origin and gives us kind of three dimensions, all right? So if I've got, let me graph it real quick here. So if I've got our normal graph here where this is the x-axis and this is the y-axis, the z-axis would be my pen coming right out at you, okay? So it kind of lets us give three dimensions to our graphs, okay? A lot of the CGI stuff that you see is graphed in three dimensions, so it doesn't just look flat. It's got some depth to it, all right? And when we talk about the graph of a three-dimensional linear equation, all right, or a three-variable linear equation, so when we talk about let me just throw some things in here. So here is an example of what we're looking at: 3x plus 2y minus 5z equals 8. All right, we could graph that in the three-dimensional plane or the three-dimensional graph here, and what we're going to get is a plane. All right, and think of a plane kind of like this infinitely large sheet of paper. Okay, so that's what the graph of this 3x plus 2y equals 8 would be a line. If I throw in that third variable, we get this graph of this plane. So if we're looking at a system of these, and again, a system of equations is just more than one of these, all right? And we're going to be looking particularly at three variable linear equations, and we'll look at some examples on the back. We're going to be looking at intersecting planes, and this is actually out of your book. You can look at this picture maybe a little bit clearer on page 374. But if I look at three planes here, there's three different possibilities, and we're going to look at all three of these today. Those three planes may meet at one and only one point. Okay, they might meet, but not at, or well, they might not all meet. All right, they might be here, or not. There's not a point where all three of them meet. Or maybe all three planes meet, but they meet in a line, an infinite number of points. Okay, so just like when we were talking about two variable equations, we're going to have one solution, a possibility of one solution, of no solution, and infinitely many solutions. All right, so to find this point, right, to find, hey, where is that point that where these three planes meet, we could use the same techniques we did before for substitution and elimination, but with three variables, this can get pretty hairy, get pretty lengthy. So we're going to look at instead at how we use our graphing calculator to solve these. Okay, so if we take a look here, all right, the first thing before we get going with this is we have to understand this this new word, a matrix. All right. A matrix is just a rectangular array of numbers and rows and columns, and every system of equations can be written as a matrix, okay? And what we do is we write down only the numbers, only the coefficients, ignoring all the variables, and also kind of ignoring the operation symbols and the equal signs, all right? So for example, here is a system of equations, okay? A system, we've got three different equations, three variables, okay? So to write a matrix for that, I simply go through and write every number that is there, all right? So this would be 2. There's a understood 1 in front of that y, 8, and -1. That's the first row. The next row would be 1. And again, subtraction, change that to adding the opposite. So that would be a -1. That would be a 1. And that would be a -2. And here, this would be 3, -2, -2, and 2. And then a lot of times we put this, you put those symbols around a matrix. And a lot of times this is what's called an augmented matrix, because we've got not only, the the variables themselves, but also the answers here. So this is how we would write that matrix. Okay. So again, that's all a matrix is. It's just this collection in rows and columns of numbers. All right. Now we can, and I wish we had more time. We could do some math on matrices. All right. I'm going to matrices. All right. We're going to talk about it later, but matrices is just the plural of the word matrix. So we can, add two rows together. Okay, I can add these two rows together if I want and have that row replace one of the rows that I have. I can multiply any one of these rows by any non-zero number that I want. Okay, this is similar to what we did back when we were solving systems of equations by elimination. We'd multiply equations by the same thing, or we'd add two equations together. Okay, we can do the same thing with these equations, but really what a matrix allows us to do is do it a little bit quicker without all the x's and y's. But understand this this connection here. Okay, so our goal in solving a system of equations, if I'm asking you to solve this system of equations, again, graphically what I'm asking you to do is, if these are three planes, tell me the one point where those three planes meet. Or probably a better way to think about it is algebraically, what is the x, y, and z that I can put into all three of these equations and it makes all three equations true? All right. So if we look at this, we're going to want to take this matrix and put it into what's called reduced row echelon form. We're going to take a look at that a little bit later, and we're going to see why it's useful. But right now, I'm going to teach you, okay, how to do this on your graphing calculator, on how to take this matrix and write it in this reduced row echelon form, and then we'll hopefully see why it's useful. All right, so grab your graphing calculator. All right. And right here in blue, all right, you should see the word matrix. All right, so since it's in blue, I need to hit second, and then I'm going to hit that button. Now, you might not have anything here. It depends on if you've used your graphing calculators for these before. But we're going to go over to Edit. Okay, and we're just going to work all in matrix A. Again, you could put a bunch of different matrices in here. We're going to stay just in matrix A. All right, so that's the name of that matrix. So 1 is highlighted, so I can either hit 1 or I'm just going to hit enter. All right, and this is what's called a 3x4 matrix. 3 rows by 4 columns. All right, and I've already got this set up. Okay, but if you don't, you just type in 3 and hit enter, and it moves automatically to the next one. Type in 4 and hit enter. All right, and now I'm going to enter these numbers in, and as I hit enter, it's going to move to the right. All right, so the first row I want to do is 2, 1, 8, and -1. All right, so I'm going to type those in. 2, and then I hit enter. 1, hit enter. 8, hit enter, and then -1, and again, make sure you're using the negative button, not the subtraction button there. So -1 and hit enter, and you notice it automatically moves down to that second row for me. All right, so I'm going to hit 1, enter, -1, enter, 1, enter, and then -2, enter. And then finally, I'm going to enter that third row. 3, enter, -2, enter, -2, enter, and 2, enter. Okay, so now I've got that matrix. I've got this matrix. This is now in my calculator. This is now the matrix called matrix A. All right, we give it a name so we can do some math with it. All right, now to get out of this, I want to go back to my home screen, and that's always just second quit. So I'm going to hit second quit, and that takes me kind of back to my home screen. Okay, now we've got that matrix in our calculator. To put that in reduced row echelon form, again, I'm going to go to my matrix menu. So second matrix, and now I want to do some math on this. So I'm going to scroll over, and you notice there's a lot of different things we can do here, but we are actually going to go down to number B, letter B, RREF. Can you guess what that stands for? If you said reduced row echelon form, you are correct. So once I get down there, I can just hit enter, and it says, all right, I'm going to do the reduced row echelon form of what matrix. So this is, if you've got more than one matrix in there, you need to tell your calculator what matrix you want it to look at. Now we've only got one, but we still need to put that in there. So again, I hit second matrix, and now I want to choose, I'm on names, and I want to choose matrix A, so I can either hit 1 or just hit enter since it's already highlighted. So this, your calculator says, hey, I'm going to do the reduced row echelon form of matrix A for you. It says, I'm going to take this matrix and I'm going to put it in reduced row echelon form. And we're going to look at that and then we'll see why it's useful. So you go ahead and hit enter. And it gives you this new matrix. All right, let me, whoops, hopefully you got that. Okay, and I'm going to copy that down on my paper. So it was 1, 0, 0, 2. 0, 1, 0, 3, and 0, 0, 1, negative 1. So this is kind of a basic example of what's called reduced row echelon form. Reduced row echelon form gets every leading coefficient to 1. Okay, and fills in zeros to the rest of these except for that last column. And then it kind of works like stair steps. So the next one is always to the right of the one above it. And then the next leading one is always to the right of the one above it. Okay, so here is that matrix. Now, again, I wish we had more time. I wish, that we could look at this, but these two matrices are identical. They're the same matrix. They look completely different, but they are. Go back to, think about how we could, solve this by elimination. But take a look at what this means. So what's the so what? Well, if we go back here, remember this was 2x plus 1y plus 8y equals negative 1. If we kind of do that backwards, this is 1x plus 0y plus 0z. So we've got 1x equals 2. We now know what x is. This is 0x plus 1y plus 0z equals 3. We know that y equals 3. And we've got 0x plus 1y plus 1z equals negative 1. So we know that z equals negative 1. We just solved that system of linear equations. And I'm not going to take the time to do this right now, but I'm telling you, if you put those three values in, we'll do it in one of them. I'm going to do it in the top here. All right. So it's x is 2, y is 3, z is negative 1. If I put those values in the top, 2 times 2 is 4. Plus 3 plus 8 times negative 1 is negative 8. 4 plus 3 is 7 plus negative 8. Yep, it works. And I'm telling you, if you put those three values in the other two equations, they're also going to work. Okay, so we have solved that system of linear equations in 3 variables using our graphing calculator. Okay. Now let's look at some other examples here and just some special situations of what could happen here. And then I'll let you get started on your homework. So here we go. It says use your graphing calculator to solve these. So again, I'm going to come up with the matrix first. So it's, again, I write down, there's ones in front of each of those. So 1, 1, 1, 0, 1. Now, and here's why I threw this one in. You notice there's not a y. I have to remember to fill a 0 in there if they leave the variable out. 1, negative 1, 1, negative 1, negative 1, and 2. Okay. So there is that matrix. There's the matrix for that system of equations. So now I'm ready to go back. I got to enter my new matrix here. So second matrix. And again, I want to go over to edit because I want to enter a new matrix. And I'm just going to put this back at A. So it's still a 3 by 4. So I can just hit enter, and it'll move me right to my matrix. And now again, I'm going to enter it by row. All right. So I'm going to put 1, 1, 1, 0, 1, 0, 1, negative 1. And 1, negative 1, negative 1, and 2. Okay, so now I've got that matrix entered. Let me go back to my home screen. So second quit. Okay, now let me show you a neat little hack here. Okay, if I hit enter again, okay, it's automatically going to give me the reduced row echelon form of matrix A. But now matrix A is completely different, so that's what we wanted to do. We don't need to go back all through that. So if I hit enter again, it's going to give me now this new matrix here. Okay, so here, and again, really all you have to do is just read down this right-hand side because you've got 1x and the rest are all zeros. So x is 1, y is 1, and Z is -2. Again, you can go through all the math and stuff again, but if you're the last thing you did was put matrix A in reduced row echelon form, that's what it's going to do again, but now it's going to look at your new matrix A. So, it does save you a little bit of time on this. Okay? So just wanted to show you that one. Just make sure you fill in zeros where appropriate if they leave out a variable. Okay? Let's take a look at this one. All right, so I'm going to come off here to the left since I kind of ran out of room here. So again, I write my matrix 2, 1, -1 and 4, 1, 1. There is no Z, so I fill a 0 in there, and 2, and then 3, 2, -1, and 6. So there's my matrix for that system of equations. So let me enter that in. So second matrix, and I go over to edit. And now I'm going to enter those values again. Remember, I'm entering them by row by row. So 2, 1, -1, not -2, -1 and 4, 1, 1, 0, 2, and then 3, 2, -1, and 6. Whoops. And so I made this mistake on purpose just to show you guys what not to do. When I started entering my data, I forgot to hit enter and enter, so it was doing a 2 by 1 matrix, 2 rows by 1 column. So all that I just did was completely useless. So let me scroll back up here and go over to number 2. Let me try this again. So I want to do a 3 by 4 matrix. And now let me enter all that information again. All right. Again, just important to show you guys how not to do these. So here we go. 2, 1, -1 and 4, 1, 1, 0 and 2, and 3, 2, -1 and 6. All right. So there's my matrix A. So again, I hit second quit. And again, the last thing I did was put matrix A in reduced row echelon form. So if I just hit enter, that's what it's going to do again with my new matrix. All right. So now you'll notice, all right, hey, wait a minute, something's goofy is going on here. Look at that bottom row, all right? I get, really, if I would write this out, it'd be 0 equals 0, all right? That's always true, all right? So 0, 0 is always going to equal 0. No matter what I put in here for X, Y, and Z, all right, it's always going to make that true. That means there are many solutions to this one. Remember, we talked about the 3 possibilities here, that you may get one solution. That's what the first 2 look like. You may get many solutions. All right, that's what this one looks like. Okay, I'll give you two guesses what the next one's going to look like. But here is what a many solutions looks like, is if I get a row of all zeros. Because this equation is always going to be true, all right, regardless of what I put in for X, Y, and Z. Now notice here, it's not any solution, because X plus Y has to equal 0. I'm sorry, Y plus Z has to equal 0, and X minus Z has to equal 2. So there are some certain restrictions. I'm not asking you to find those, but just make sure you write down many solutions, not any solution. Okay, so this one we're probably pretty sure is going to be a no solution, but let's see what that looks like. Okay, so here's my matrix: 1, 2, -1, 3, 2, 1, 2, -1, -2, -4, 2, and 5. Okay, there's my matrix for this system. All right, so let me try to do this correctly this time. So second matrix, and no, I want to go over to edit. And yes, it's a 3 by 4. I need to make sure I hit enter so it gets into my matrix. Now I can start entering those numbers. 1, 2, enter, -1, and 3. Make sure you hit enter after each one. Otherwise, you're going to put -13 in there instead of -1 and 3. 2, 1, 2, and -1, and -2, -4, 2, and 5. Okay, so there's my matrix. And so second quit takes me back to my home screen. And again, I want to do matrix A in reduced row echelon form. Matrix A looks completely different. Holy cow, now this looks weird. So I'm getting some decimals here. This would be 1 2/3. This would be -1 1/3. You notice this little arrow here, so I got to scroll over because right now I'm only getting the first 3 columns. And again, take a look at this bottom row. So I can scroll over All right. And take a look at that bottom row. I get 0 equals 1 this time. That bottom equation is never going to be true. 0 plus 0 plus 0, because these would be x, y, and z. And no matter what you put in for x, y, and z, it's going to be 0 plus 0 plus 0 equals 1. That's never going to happen. So this one actually has no solution, which means if we would graph it, they might intersect, but they're not. Not all three of them are going to intersect. Here, 2 of them intersect, but this one doesn't. At this point, 2 of them intersect, but the other one doesn't. Or maybe they are parallel planes that are never intersect. Regardless, this one has no solution, and that's what that looks like when I get 0 equals 1. All right, so catch that difference between many solutions and no solutions. Okay, all right, but again, using technology to solve these 3 variable equations, all right, using matrices and reduced row echelon form. All right, so here's the problems that I'd like you to do. Get those taken care of, and make sure you share your answers with me on Flipgrid. Let me know if you have any issues. Take care, guys.